Good afternoon, everybody. So I was in charge to moderate this special session on devoted to milestone of Alexei Abrikosov works. And my name is Arkady Zhukov. In fact, I'm not working in superconductivity, but I was one of his students, and therefore, so I knew him personally, but I have known more things to say about this. And this, can you the second slide? So initially the program was that we will have a free presentation, but finally Alexander Buzdin canceled his application presentation because of force majeure reasons. Please, can you proceed with the next slide? So this is in fact the initial program of this special session. And please, next slide. So, and in fact, well, I just, yeah, thank you. I just placed several, just couple of slides that, in fact, I knew Professor Abrikosov because of his work in Moscow Steel and Alloys Institute, because at the time I was student. And here you can see some just part of his biography. And his, well, unfortunately, you see only part of the slide. And I think the Professor Varlamov and the Professor Vinokur will present very interesting facts of his biography and his milestones, because Andrei was one of the PhD students of Alexei, and Professor Vinokur was working last years of his research career in Argonne laboratory. So in my case, I just was the student, and then after that I was working in Chernogolovka and in different institutes. And then I just finished my very short introduction. And
Andrei Varlamov with his serious talk will be the second, and they have to start. But what I was going to tell you, it's not going to be serious, because it will be just 3 stories. And one is not a story, but one is the fact which actually probably almost nobody pays attention. And another 2 are the stories in which I participated, but which characterize this greatest scientist pretty well. So not the story number 1. Everybody knows what is the main source of glory of Abrikosov, his prediction of what we call now Abrikosov lattice. And this paper was published in this GETP in 1957. And it's an excellent paper, just on every count. And well, and when I was reading this paper, I paid attention to one thing, which is absolutely normal in the scientific papers, but then I found out that nobody pays attention to it. Actually, the phase, which Abrikosov called mixed phase in this paper, and which carries vortices, was sort of discovered well before that. And it was discovered by Lev Shubnikov. And it was carrying for quite some time the name of Shubnikov phase. And in his beautiful paper, Abrikosov gives very detailed account of this experimental work by Shubnikov, compares the experimental data obtained by Shubnikov with the prediction of his theory of the vortex lattice, and demonstrates beautiful agreement between experiment and the theory. And nobody pays attention to the fact okay. So the paper was published in 1957. If one will read attentively the even more famous paper by Ginsburg and Landau, where they found out, well, everything about superconductivity and introduced that there are actually two types of superconductivity. One is when kappa is less than 1 over square root of 2, and another one when kappa is greater than that, which now we call superconductors of the second kind. And then those who read this paper attentively, I mean Ginsburg and Landau, should notice that the paper is written somehow with a careful analysis of what is happening at small kappa, but then it looks like this, okay, kappa, which is greater than 1 over square root of 2, doesn't exist at all. I was talking to different people. Nobody was actually like paying attention to this fact, and nobody could answer a simple question, why? Volodya probably can right away. Because, and of course, Landau knew about Shubnikov phase because they were very close friends with Shubnikov in Kharkov. And the explanation is trivially simple for everybody who lived in Soviet Union. One of the greatest scientists, experimentalists of our century, Lev Shubnikov, and we all know his name from textbooks, Shubnikov, the gas oscillations, of course. Well, he was shot to death in 1937, declared the enemy of the people, and, well, and executed. And mentioning his name in 1950, when Ginsburg-Landau paper was written, was a simple and 100% suicide. So, of course, Ginsburg and Landau didn't do it. Landau served his sentence in prison for 1 year, and so he knew pretty well what everything means. But Shubnikov was rehabilitated only in 1956. Actually, it was Landau who wrote a strong letter to the general prosecutor of the Soviet Union and demanded Shubnikov's rehabilitation. Abrikosov paper was published in 57, and actually to publish this careful analysis and comparison with Shubnikov's data was an strong act of courage and real act of great courage, because nobody knew in 1957 how the political development will turn, and it could have happened very well that Shubnikov will be declared with all other victims of Stalin's regime, again, an enemy of the people and everybody. And so Abrikosov was taking quite a risk doing that. So this immediately, when I realized it, it immediately sort of told me a lot about Abrikosov's personality. He was a brave person, courageous, and quite capable for actions. Alas, most of the people are not capable for. So this is not a story. This is just everybody can just read this paper by Abrikosov and read this careful analysis which Abrikosov presented there. And another two were just funny stories in which I participated. So Abrikosov was a strong personality, well, genius of science. Sometimes his opinions were quite strong, so it will be inverse chronological order. Sometimes his opinions were quite strong, and he didn't hesitate to express them. But he had another beautiful quality. He could reverse his opinion once he learned that he might have not been quite correct. And he didn't hesitate to tell it publicly that he was wrong. So the story was like that. Okay. Soon after he joined us at Argonne, I invited my good friend, Professor Gianni Blatter. Many of you know him pretty well from Zurich, from Switzerland, to tell about our and his latest achievements. And Gianni Blatter was giving a beautiful talk about vortices in these high temperature superconductors. And at some point, Abrikosov lost his temper and said, commenting on his work, it's really painful to watch how one idiot, Professor X, he is still alive, so I won't mention his name, is using idiotic analogies between vortices and some sort of flexible lines like polymers, and other people like Monkey, and he just showed to Professor Blatter, repeating this idiocy without any hesitation. Okay, I was a little bit uncomfortable because Gianni Blatter was my guest and I was supposed somehow to protect him. So I stood up and said, yes, analogies are always very misleading, but sometimes some scientists use them. And I know an example of one scientist who used the analogy of the behavior of the charged particles in the magnetic field with the quantum oscillator. And what came out from this maybe unjustified analogy, we now call Abrikosov lattice. The reaction was immediate. In the audience, everybody laughed. Abrikosov sort of shut up, didn't comment anymore. And after the talk, I just stopped by in his office and asked, okay, Alexei Alexeyevich, so what's wrong? And he said, it's absolutely idiotic. You consider vortices like a pot of spaghetti. It's like, it can be. I said, well, it's a beautiful image, a pot of spaghetti, and actually it's sort of right. However, you have slightly distorted image. So what's that? Asked Abrikosov. Okay, you just consider a pot like the usual pot, sort of flat, but imagine the pot which has the height 1,000 times more than its diameter. And these vortices, yes, they're like spaghetti, but they go all the way down along the walls, almost straight. And yes, of course, they're sort of flexible. But they sort of bend so that they can exchange their position exactly on the distance, which is 1,000 times more than the diameter of this pot, and their displacement is just about the distance between vortices in this case. And then Abrikosov said, that's the image. I said, yes, okay, let me think. I left the office, in 3 hours in the corridor, going with Professor Gianni Blatter, we ran into Abrikosov. He smiled, he turned to Gianni and said, oh, I thought a little bit. Your theory is great and really elegant. Now I understand everything. Good. Thank you very much. I was wrong. And then he added, but Professor X is an idiot. And another story happened long before that, back in Moscow. And again, Abrikosov sort of expressed his personality and behaved really like, a person capable to the action. So again, those who lived in Moscow at that time, in 80s, know that it was like a school there, high school, for mathematically gifted children. School number 57, which was sort of like inherited, the quality of what is called Lyceum, now Lyceum number 2, school number 2. People who lived in Moscow know that. I was educated from this mathematical school. Dima Gishkinbein, for example, in a few years after that was also graduated from this school. This school was closed, then recovered. And then in 80s, the school number 57 was one of the most beautiful high schools in Moscow for, I repeat, mathematically gifted children. And it was quite famous. And everybody, of course, everybody's parents' dream was to have his kids to study in the school. Well, not everybody liked the school because there were some party officials, I mean, Communist Party, who wanted their kids to study in the school, but they didn't want their kids to pass through quite tough exams. And of course, the chief of the school also was courageous enough to deny their acceptance if they won't pass the exams. And then these party officials decided that it's a very good time to shut down the school, to give a good lesson to everybody who is disobedient. They invented immediately a good reason that the building is in very bad shape. It's necessary to repair the building. The school should be just destroyed. All the teachers sent to other different schools. Well, it was a disaster for the school. And then there were people who decided, to make everything possible to save it. Different measures were taken to save the school. People found to repair the building indeed. And then it was one of the ideas, it was also perestroika times. And it was the idea which we had that if at least one great scientist writes the letter to the secretary of the Communist Party, and actually we had one person in mind, Alexander Yakovlev, who was sort of spiritual leader of perestroika, that we have to write a letter to him and ask one of the great scientists to sign this letter. Well, together with my friend from Landau Institute, we composed the draft. And then it was, the first idea of the friend of mine was to approach some indeed very good scientist, very good person, and then even a friend of mine. I predicted that this guy is not going to sign this letter. And indeed, he delivered half-hour very well-willing lecture and gave a beautiful explanation. He didn't say, I won't sign this letter. He proved 2 by 2 why this letter should not be signed at all. And it was with a good smile and very convincing. And I said, as I predicted, now let's go to Abrikosov. The friend of mine was sort of desperate and he said, you go alone. I went alone. I approached Alexei Alexeyevich. I told him the story. Abrikosov told me, let me see the letter. I produced the letter. He started to read it, was not quite happy. And he said, the letter should be edited, he said. And then I decided, of course, if the letter will be somehow softened, it's it's not bad, because if it will carry his name, it still will have some meaning and effect. And Abrikosov took a pen, crossed some lines, wrote something instead of, crossed another line, wrote something instead, then gave this letter to me. I read the letter. It became at least 10 times stronger than what I dared to write. Abrikosov looked at me and asked, so what do you think? Well, there is some improvement. So we were talking at Kapitsa Institute. Abrikosov took this draft, we came to Kapitsa typewriter. She typed this letter. Abrikosov signed it. Then he gave it to secretary, told her to put official Kapitsa Institute stamp and address to that, and send it to Central Committee of the Communist Party as an official letter from the Kapitsa Institute. Well, this was not the only factor, probably, but probably it was like, okay, it played its role. And then Abrikosov once again, like, demonstrated that he is a person quite capable to do some action of courage. Well, he didn't risk his life, of course, at that time. It was perestroika time, but other people didn't want to sign it anyway, because they were afraid of some, like, God knows what. Abrikosov was not afraid. Those basically just like, okay, there were many other stories showing Abrikosov outstanding and very interesting personality. But I think that, well, maybe these 2, 3, like, give enough account of what kind of person he was. Thank you.
Thank you very much, Valery, for your presentation and for your help. And now I think we have another speaker, Professor Varlamov, online.
So I'm grateful for organizers for this invitation, for possibility to memorize my teacher. And I will start to, okay. So I would like to speak about the Nobel Prize winner, Alexei Abrikosov, his unusual life and scientific achievements. So when one undergoes an examination on a magnetic resonance imaging machine in a hospital, reads about the discovery of the Higgs boson at the Large Hadron Collider, or about setting a new speed record for train on superconducting magnetic cushion, then behind all these fantastic achievements of modern technology lies the practical use of the phenomenon of superconductivity, and hence the figure of the outstanding theoretical physicist of the 20th century, Alexei Alexeyevich Abrikosov. The family of Abrikosov was well known in the Russian Empire and in Soviet Union. Alexei Abrikosov was born on 25th June of 1928 in Moscow in the family of well-known physicians Alexei Ivanovich Abrikosov and Fanny Wolf. Alexei Ivanovich Abrikosov was vice president of the Academy of Medical Sciences. He was the author of the handbook on which the generations of Russian medicines about the pathological anatomy, so the generations of Soviet physicians grew on this book. His bust is close to the first medical university of Moscow even now, but mostly he was famous because he performed the autopsy of Vladimir Lenin. So he was the carrier of the top secret what from died Lenin. In his turn, he was the grandson of the Alexei Ivanovich Abrikosov the older, who was practically the founder of the dynasty of Abrikosov. The Abrikosov's family was known in the Russian Empire from the early 19th century as the founders and owners of confectionery shop, which gradually became a large concern and was awarded the title of supplier to the court of His Imperial Majesty of Chocolate. Here I will show you some unique pictures of the early childhood of future Nobel Prize with his father, and that he was very even in very young ages, he already worked. And these pictures were scanned from the diapositives of 1930, but the nephew of Alexei Abrikosov, Natalia Abrikosova. Another outstanding person from this family was the brother of his father, so the uncle of Abrikosov, Dmitry Ivanovich Abrikosov, who was the last ambassador or charge of the affairs of the Russian Empire in Japan. Actually, he wrote the beautiful memoir, Revelation of a Russian Diplomat. And here you can see two brothers in student uniform. And actually, he did diplomatic career, and the February Revolution of 1917 found him in the embassy of Russian Empire in Japan. And actually, during the 8 years until 1925, where Japan established diplomatic relations with Soviet Union, he provided the immigrants from, not immigrants, the people who escaped from communists, he provided by documents to help them to start new life in West. Another person, so I want to stress that Alexei Abrikosov is not only the Nobel Prize, but he also is a nephew of Catholic servant of God, of Anna Ivanovna Abrikosova. Anna Ivanovna Abrikosova was a sister of his father, and she was a Russian Greek Catholic religious sister, literally translator and victim of Joseph Stalin concentration camps. She was also the foundress of Byzantine Catholic community of the Third Order of Saint Dominic, which has gained wide attention even among secular historians of Soviet repressions. In an anthology of women's memoirs from Gulag, Anna Abrikosova is described as a woman of remarkable erudition and strength of will. She is also mentioned by name in the first volume of the Gulag Archipelago by Alexander Solzhenitsyn. Since 2002, Mother Catherine's life has been under scrutiny for possible beatification by the Holy See. Her current title is a servant of God. Here, Valera Vinokur told about the ability of Abrikosov to write letters. So I remember it was 1993, and I was working in group of Abrikosov in Argonne National Laboratory, and this period, the Papa Wojtyla baptized a lot of martyrs of communism from Poland. And Abrikosov read about this, and he thought, oh, my aunt also suffered from communism. And he wrote the letter to Wojtyla and attracted his attention to the destiny of his aunt. In result, he is now passing the procedure of beatification. Okay, now years of studying. In 1943, 15 years old, Alexei Abrikosov graduated from high school and entered Moscow Power Engineering Institute. Soon he recognized that engineering is not his destiny, and he transferred to the Faculty of Physics of Lomonosov State University. Here you can see the old building where he started his education, and here you can see a well-known skyscraper of the modern Moscow State University. He very early became a pupil in the Landau School. Landau School of Theoretical Physics merits to be discussed separately. The Kharkov Theoretical Physics School was founded by Lev Landau in Kharkov, Ukraine. It is sometimes referred to as a Landau School, more precisely. One might say that Landau's group at Kharkov was the beginning of the Landau School, that after Landau moved to Moscow included new generations of theoretical physicists from the countries of the former Soviet Union. Lev Landau was the head of the Kharkov Theoretical School from 1932 to 1937. In 1937, Landau, here you can see the Kharkov Physical Technical Institute, Pyotr Kapitsa, who is visiting laboratory in Kharkov, Lev Landau, who is discussing science at the blackboard, and here the picture from the file of Landau when he was arrested by KGB in 1937. It was Kapitsa who had succeeded to save the genius of theoretical physics. Nevertheless, the habits in Landau school are well described by this caricature. You see that Landau is a god, and his pupils are donkeys. So it was some, okay, this is some joke. Nevertheless, in each joke, there is some percentage of truth. So Alexei Abrikosov became one of the favorite pupils of Landau. His scientific growth was directly influenced by Lev Landau. At the age of 19, he passed the theoretical minimum. In a year, he graduated summa cum laude from the Faculty of Physics of Moscow State University. Here you can see famous picture of Landau group. This is Landau, Evgeny Lifshitz, his co-author by the famous The Course of Theoretical Physics, Isaac Khalatnikov, Alexei Abrikosov, Mila Prozorova. This is Semyon Gerstein, Lev Pitaevsky. This is Arkhipov. No, excuse me, please. This is Arkhipov. This is Zelashinsky, and this is Pomeranchuk, probably. No, you see, I'm wrong. This is Weinstein. Excuse me. So here you can see the list of students who passed the theoretical minimum handwritten by Landau. And you see that Abrikosov was number 12, who passed in 1947 all exams of Landau minimum. So he started in 45, and in 47 he passed all exams of Landau minimum. What is everyone who passed these exams know what does it mean. Okay, assault of the peaks, mountaineering and scientific. In 1950, at the age 22, Alexei Abrikosov defended his PhD thesis devoted to the study of thermal diffusion in fully or partially ionized plasma. You can recognize in this topic the traces of Soviet atomic project. And Landau wanted to have Abrikosov as his collaborator. So, and some difficulty appeared that in 1952, the anti-Semitism in Russia reached very high degree, the state anti-Semitism. And the mother of Alexei Abrikosov was Jewish. And during 6 months, his position was suspended because the KGB men in the human resources did not want to sign his nomination. And in this moment, so at the beginning of 1952, in January 26, the communist leader of the Mongolian People Republic, the Marshal Horlogin Chaibal's son, died. And this fact was unexpectedly played the important role in the life of Alexei Abrikosov, because in Pravda, the central communist newspaper, the first page was published the report about the origin of his sickness and why he died, and it was signed by the pathologist of Kremlin Hospital, Fanny Wolf, who was a mother of Abrikosov. So people say that this guy in human resources thought, oh, if Communist Party allowed to make an autopsy of so important person, so we should not stop Alexei Abrikosov to become the researcher of the Institute of Physical Problems. Okay, so almost 2 of the subsequent decades of Alexei Abrikosov's scientific work were spent at the Institute of Physical Problems of Russian Academy of Science. Here you can see, this is the central entrance to the institute. You see with some old cars, so these are 50s. Here is Landau with Lifshitz and Khalatnikov. This is Petr Kapitsa. And then I will show you the pictures which indeed for me are very nostalgic. Here you see, for instance, Zelashinsky who speaks with colleagues. And these pictures were, I should acknowledge Mikhail Chernikov who gave me these pictures. Up to my mind, they transfer very good, the very creative atmosphere of science which was in Landau group. You can see here how Landau discussed something with Igor Zelashinsky. Here, Moisei Kaganov, who would celebrate 100 years this year with Fix and Kanner, so people from Kharkov discuss physics. Here, Abrikosov, the blackboard, dispute something with Lev Garykov. Here, Lev Pitaevsky and Garykov discuss with Gurgy, and you see, indeed, these pictures show you the thought, the flight of scientific thought. Here, you can recognize from these formulas, this gentleman is Pippard, and this is Alexei Abrikosov, 1957. So you can easily recognize what they're discussing. They're discussing Pippard penetration waves versus London one. This is very nice. So now I will pass to the discovery of the type 2 superconductivity. In 1950, Ginzburg and Landau wrote the famous article, which was called the Psi theory of superconductivity. They wrote the functional, which all of us know, and derived equations with boundary conditions. So in dimensionless form, the only parameter, material parameter, which appeared in these equations was so-called Ginzburg-Landau parameter kappa. Today, thanks to Garykov, we know its microscopic expression. But those times, so this paper was extremely important, and great success of the Ginzburg-Landau theory was that the critical field and magnetization of a thin film was calculated. We explained phenomena of supercooling and superheating. The critical current of thin wire with kappa much less than 1 was calculated. Quantization of the magnetic flux, and was what very crucial fact that they have succeeded to calculate surface energy at the interface between the normal and superconducting phase. But this value was essential to justify intermediate state predicted by Piles and Landau, where it was necessary to have some positive surface energy at the boundaries between normal and superconducting dominions. So when kappa, they found that if kappa would become, when kappa is less than 1 over square root of 2, so always okay, this surface energy is positive. For majority, for all superconductors which were studied those times, kappa was much less than 1, and they decided that physically kappa should be less than 1 over square, should be less than this. So it is an unphysical case where kappa more than 1 over square root of 2. Very good. Experimental verification of the Ginzburg-Landau theory. In 1951-52, Abrikosov and Zavaritsky, and experimentals from Institute of Physical Problems, were engaged in verifying the prediction of the recently developed Ginzburg-Landau theory of superconductivity concerning critical magnetic fields for thin films. Now I will cite you from Abrikosov's Nobel lecture. Nikolai Zavaritsky started to measure the critical field of thin film. Theory and experiment fitted perfectly, including the change of the nature of the transition. First order at larger thickness and second order at a small smaller ones. Everything seemed okay, but Alexander Shaynikov, the boss of Zavaritsky, was not satisfied. He said that film used by Zavaritsky were bad since they were prepared at room temperature. The atoms of the metal evaporated on a glass substrate could agglomerate, and therefore the film actually consisted of small droplets. In order to avoid that, Shaynikov recommended to maintain the glass substrate at helium temperature during evaporation and until the measurements were finished. Zavaritsky followed this advice, and the result was a surprise. The dependence of the critical field on the thickness or temperature, the theory contains the ratio of the thickness to the penetration depth, which depends on temperature, did not fit the predictions of the Ginzburg-Landau theory. Discussing these results with Zavaritsky, we could not believe that the theory was wrong. It was so beautiful and fitted so well the previous data. Therefore, we tried to find some solution in the framework of the theory itself, and we found it. The equations of the theory were all entering quantities were expressed in corresponding units, depending only on the dimensional material constant, which was later called the Ginzburg-Landau parameter. Its value could be defined from the surface energy between the normal and superconducting phases. The latter, in its turn, could be calculated from the period of the structure of the intermediate state. This data for conventional superconductors led to very small values of kappa, and therefore the calculations in the paper by Ginzburg-Landau were done for this limiting case. It was also established that with increasing value of the surface energy between the superconducting and normal layers would become negative, and since this contradicts to the existence of, it was also established that with increasing of kappa value, the surface between the, so I already told that if kappa increases and reach 1 over square root of 2, so the surface energy becomes negative, what contradicts the existence of the intermediate state. So such case was not considered. Abrikosov passed to studying the magnetic properties of massive second-order superconductors. He succeeded to found, so he asked himself, what will happen if kappa is more than 1 over square root of 2? And he found the formal solution of the Ginzburg-Landau equation, but not local distribution of other parameter, but he found some periodical solution in the θ3 functions, which described some strange lattice. He identified the elements of this lattice as a vertex of normal phase where magnetic field penetrates. So in result, Abrikosov came to the conclusion that the transition from the superconducting to normal state with increasing field proceeds gradually in case kappa more than 1 over 2. The field having two critical values. First, the lower critical field, and he evaluated it, and the I will not stop at the details. All of us know how to calculate and what the physical sense of these two fields. Between these critical fields, the external magnetic field in the form of thin filaments of the magnetic flux surrounded by vertex currents gradually penetrates the superconductor. These quantum vertices form a regular structure known now as the Abrikosov vertex lattice. Having compared his results with the experimental curves of superconducting alloy magnetization obtained in 1930s, Abrikosov found a remarkable coincidence. The authors, however, explained their data by the inhomogeneity of the specimen. Here you can see the Degas and Lev Shubnikov and their experiments of 1935. This is especially Degas and two groups. It was Shubnikov and Rябinin in Kharkov and Degas with Kazimir Yonker. Very good. So Abrikosov's paper, without which it is not it is now impossible to imagine the physics and technology of superconductivity appeared in 1957, but the experimentalists only brought it to the Vertex lattice 10 years later, after direct observation using the magnetic decoration method. You can see here the original experiments of Essmann from 1967, then magneto-optical image of Vertex lattice from University of Oslo, etc. Very good. 1958, Lev Garykov formulates elegant equations of the microscopic theory of superconductivity and demonstrates the equivalence between the microscopic diffuse theory and Ginzburg-Landau phenomenology at temperatures close to the critical one. His formulation of the BCS theory in form of the green functions allows to develop the theory of superconductivity and solve a series of very important problems. For instance, in 1959, Abrikosov and Garykov elaborate the microscopic methods for studies of electron scattering by impurities in normal matter superconductors. Now there is a possibility to study thermodynamic and electrodynamic properties of superconductors. Today, every application of superconductivity are alloys. So we cannot underestimate the value of this paper. Abrikosov and Garykov in 1960 investigates the properties of superconductors with magnetic impurities and discovers the phenomenon of gapless superconductivity. This is extremely important because they find that, as you can expect, the enough large concentration of magnetic impurities kills S-wave superconductivity. And they found the critical value of it. But what was very important that they found that between 91% of this concentration and critical concentration exists the dominion or the interval of alloys where you have supercurrent, but you do not have gap in spectrum of quasi-particles. I want to recall you that in 3 years before, in the BCS theory, was Bardeen, Cooper, and Schrieffer identified the modulus of order parameter, the wave function, the order parameter with the gap in the spectrum. Moreover, for superfluidity, Landau formulated the criterion of superfluidity, the spectrum of quasi-particles should have gap. And by 3 years, Abrikosov and Garykov said that is too much. Actually, phenomenon of superconductivity can be realized even without gap in the spectrum. Very good. Further studies of superconductivity is a newly formulated microscopic theory. Abrikosov, Garykov, and Khalatnikov, using the method of quantum field theory, study the properties of superconductor in high-frequency field. Then spin-orbit interaction and a nice shift in superconductors. This was done by Abrikosov and Garykov. So this works if you will evaluate the importance of these works and you will analyze the dates of this publication, you will be surprised by the productivity of these people. Abrikosov and his student Falkovsky published the Raman scattering of light in superconductors. Then I want to do one pass back and to recall you about the Moscow Zero and development of the diagrammatic technique. So it was 1954. The green functions and the effective cross sections of the Compton effect and mutual electron and positron scattering at high energies were calculated by Dirac, Feynman, and Schwinger. They did it in the first order of perturbation theory, so they took into account polarization of vacuum on the photon propagator, and they found so quantum electrodynamics suffered from the divergent problems. The idea to smear electron charge in space was proposed by the answers depended on the electron radius. So Abrikosov, Khalatnikov, and Landau in 1954, they studied asymptotic behavior of the photon propagator at large momenta. They proposed a procedure which for us today is trivial. They just collected the ladder of diagrams, and they select diagrams by alpha n log n in power n. And they wrote Schwinger-Dyson equation, solved it, and they found that propagator does not depend on the size of electrons hidden in this procedure. It is interesting that Landau believed that they did mistake. So in unpublished, so in preprint here was not minus but plus. And Landau was very happy about this and spoke about asymptotic freedom. Fortunately, this mistake was corrected at the level of preprint and was published with correct sign. Nevertheless, propagator with plus exists in quantum chromodynamics, and Gross, Wilczek, and Politzer 20 years later derived this propagator and got Nobel Prize. Very good. In 1959, following the works of Matsubara, Migdal, and Galitsky, the new temperature diagrammatic technique was developed by Abrikosov along with Gorykov and Zeloshinsky. It was based on their achievements in quantum electrodynamics and some other beautiful ideas. The method of analytical continuation of Feynman diagrams from imaginary to real frequencies, etc. So they wrote famous book on which the generations of theorists grew, the methods of quantum field theory in statistical physics. It was notoriously that the book was published in 1961, and it was demonstrated in the exhibition of the achievements of people economy in Moscow simultaneously with the rocket Vostok, which delivered Gagarin in space. They got the gold medal of Landau later for this book. Kondo problem. In 1960s, Abrikosov's scientific interests moved toward the theory of normal metals, semi-metals, and semiconductors. He was engaged in the Kondo problem and found that depending on the sign of exchange interaction, the effective scattering either vanishes or increases greatly. So then he did another seminal paper with Leonid Falkovsky. They formulated the theory of energy spectrum for the Bismuth type semimetals. Here, first time in solid state appears Dirac spectrum. So it was 40 years before Nobel Prize for graphene. Semimetals and gapless semiconductors, prototype of the future Dirac materials. It was done with another student of Abrikosov, with Sergei Benislavsky. Mapping of the gapless semiconductor problem on the theory of second order phase transitions. So all this was done in very short on the importance of this paper. My attraction was attracted by Igor Herbut because he listened to my talk where I skipped this paper, and he told that it was very important for their recent activity. So these papers of 60s are still very important. Okay, Soviet physics in vacation, high to the taiga. So from Professor Yuri Galperin recalls, in 1971, I, at that time a young postdoc, had luck to be accepted to a mountain hiking team planning a route over the academician Obruchev Ridge, located between the large and small Yenisei, Great Siberian rivers. The team consisted of 3 theoretical physicists, 1 biophysicist, 2 engineers, medical doctor, and architect. The oldest member of the team was Abrikosov. The route was rather complicated. It contained mountain passes. It was planned to spend about 40 days out of civilization. Consequently, we had to carry heavy backpacks, 2 rifles for hunting and defense from bears, typical animals for that area, with ammunition. Under such rather severe conditions, personal features of human beings clearly manifest themselves. In particular, Abrikosov always checked that his backpack is not lighter than other ones. He managed to keep a good mood under rather difficult conditions, in particular when we were trapped in a valley by unexpected snowfall. He was ill and had high fever. Snows of Kilimanjaro. Professor Evgeny Onishvili, Kilimanjaro Ascent Leader, 1968. Walk around our beautiful country, the voice of the head of science department of the Leningrad Regional Committee of the Communist Party of Soviet Union sounded like a verdict not subject to appeal. I silently left the office. A year and a half of efforts to organize an expedition of the Geographical Society of the USSR with an ascent to Kilimanjaro crashed. A desperate visit to the Central Committee of Communist Party did not bring results. The young referent sympathetically said, "They will not let you out." However, the impasse was unexpectedly resolved by inviting 3 Muscovites to participate, 2 of whom had the title of Lenin Prize laureates, and one of them, Alexei Abrikosov, also had the status of a corresponding member of the USSR Academy of Science and was one of the world-leading theoretical physicists. On February 23, 1968, we were approaching the start of our multi-purpose route. In addition to the main task of the group of the Geographical Society of USSR, the first Soviet ascent of Kilimanjaro, it was planned to climb Mount Kenya, located, etc., etc. March the 1st, 1968, early morning, the monkey skin blankets of the Marangu Mountaineering Hotel have been dropped. The previous evening, a statement was signed with the hostess of the hotel due to the refusal of porters and guides. The group was warned about payment from their own funds for possible rescue operations. 3 Leningraders and 3 Muscovites are going to the ascent with full gear. It is necessary to overcome the difference in altitude of more than 4 kilometers. The most original perceived lack of shadow under the feet, this is practically the equator. The peasant women we met with huge bunches of bananas on their heads shied away in horror at the sign of white Bovana gentlemen carrying their own backpacks. The explanation was very simple. They just did not have money because the state did not allow them to change rubles in convertible currency. Okay, so from this I will pass to 70s, and I will be very short. I will just say that Abrikosov explained transition of bismuth type semi-metal to an excitonic in strong magnetic field. So his interests now are devoted to this low-dimensional system, to properties of one-dimensional system. He with Ivan Rishkin do contribution to quasi-one-dimensional physics, electrical properties of one-dimensional metals, role of phonons, etc. I will stop about science, and I will say several words about the active scientific, organizational, and pedagogical work of Alexei Abrikosov in Landau Institute. He was one of the founders of this institute together with Lev Gorkov, Isak Khalatnikov, Igor Zavashitsky. Here you see the first building of Institute of Theoretical Physics, which was actually planned as the custodian house for Institute of Chemical Physics. In 1987, Abrikosov published a book, Fundamentals of the Theory of Metals, which was based on his brilliant lectures, courses delivered to the Moscow Institute of Physics and Technology and Moscow Institute of Steel and Alloys. This book became an encyclopedia of the theory of normal metals and superconductors. Since 1976, Abrikosov headed the Department of Theoretical Physics at the Moscow Institute of Steel and Alloys. Here you see the building of Moscow Technological University modern laboratories, and here's the picture of 1984, probably 5. Here you see Alexei Abrikosov, Lev Slomazov, Yuri Vikilov, Sergei Limpitsky, Mikhail Fistul, and it is me who was a little bit younger, I think 35 years ago. So now about the pedagogical, about again scientific organization of Alexei Abrikosov, which was very important for Soviet theoretical physics. These were Odessa symposiums in theoretical physics of Landau Institute, organized together with Odessa University by Alexei Abrikosov and Isaac Khalatnikov since 1961 until the end of 80s. Anybody who had occasion to meet Abrikosov, to work with him, to participate in the regular symposia on theoretical physics organized by him, remembers his erudition and adherence to principles, his teller's gift. Here you can see the portraits which were designed by, painted by Leonid Maximov, the Russian academician and brilliant physicist who had a gift also of painter. So these are charges for Khalatnikov, Falkovsky, Slomazov, and Abrikosov himself. Abrikosov also devoted his attention to, he was very attentive with experiment, and he always taught me that you have not right to finish the article with some correlator. You should present at the end some formula which can be measured by experimentalists. Abrikosov with Mikhail Khaykin organized a series of schools, physics of metals. Here you see the first of them in Kazan. This is probably the last, not the last. The last was in 91 without Abrikosov, but this was the last where Abrikosov was. It was in Tajikistan. And here you can see Boris Altshuler, me, Robert Schechter, Misha Gershenzon, Arkady Spiegel, so Vladimir Shaternik. So it always in beautiful places we had beautiful physics. Abrikosov with his pupil, this is a charge of painted by Alexei Tsvelik in 1978. We presented it to Abrikosov for his 50 years anniversary. You see that here he has in the let's say in the dresses of God, he has his green book, The Method of Quantum Field Theory in Statistical Physics. In the period from 1988 to 91, Abrikosov headed the Institute of High Pressure Physics of the Russian Academy of Science. At the beginning of the 90s, Abrikosov accepted an offer to head the theoretical group in the Argonne National Laboratory and left for the USA. Here you see it was the exciting period of detailed study of high temperature superconductivity, and Abrikosov participated in it together with Campuzano. Here you can see we were with Sasha Buzdin, who was supposed to speak about this period. Unfortunately, he is not. He was not able now to deliver his part of talk. So this is Carlos Adimela, he was postdoc of Abrikosov. And the most intriguing problem in condensed matter physics in those days was the explanation of the phenomenon of high temperature superconductivity. And Abrikosov, in close contact with the experimentals of the laboratory, devoted himself to studies in this field. They revealed the existence of specific singularity in the spectrum of cuprate superconductors, after which Abrikosov proposed his version of the theory of high temperature superconductivity that explains the variety of the existing, those times experimental findings. Main ingredients of his theory were BCS nature, Van Hove singularity in the spectrum of quasiparticles, and resonant tunneling along the axis. The last foresight. The probably last original paper of Alexei Abrikosov was published in '98. It was devoted to the quantum magnetic resistance. I heard from many people who 10 years later devoted themselves to studies of graphene that they were inspired by this paper. I advise you to take a look at this paper. It is written very simply and very clearly. You recognize a lot of origins from all the Abrikosov papers here, but it is so nice to read it. I enjoy it very much. He attributed this linear magnetic resistance in non-magnetic silver Hawking measured by Louisa Sabonge and co-authors to the linear spectrum, and it was in some sense pro theory for graphene physics. Here you see the Abrikosov's 70th birthday symposium, which was celebrated in Argonne. You see here Boris Spivak, Dick Clem, George Crabtree, Boris Shklovsky, Boris Altshuler, Lev Garykov, Anderson, Zeloshinsky, Dima Khmelnytsky, Valera Vinokur. So a lot of this, it seems, Peter Littlewood. So we see this is Brand. So we see a lot of famous people here. Here, the meeting of 3 co-authors in 40 years in Argonne National Laboratory. Here I spoke about, here I show some pictures when Alexei Abrikosov was our guest in Italy in the Institute of Nuclear Physics in Rome, in the Fermi laboratories. He visited also Camerina, his old co-author Sergei Chudinov. And here I show you the pictures. This is the Dima Rodichev, Alexei Abrikosov, and me in Crete conference, where this is 1 week before Nobel Prize. And then October 5th of 2003, Argonne National Laboratory spontaneously celebrated the Nobel Committee announcement. Here you see the ceremony of awarding Nobel Prize. Here you see the reception of Alexei Abrikosov by George Bush, the director of DOE. And I want to attract your attention that actually Alexei Abrikosov is a Nobel Prize in the 3rd generation, because he was the pupil of Nobel Prize Lev Landau, who considered himself as a student of Niels Bohr. So the Nobel Prize of Abrikosov is the Nobel Prize in the 3rd generation. Here you see that Dmitry Levanov, those time the Minister of Science and Education of Russian Federation, who was an alumni of the Department of Theoretical Physics, visits Abrikosov to discuss with him the ways of development of Russian science. Here, it is my last scientific discussion with Alexei Abrikosov at the blackboard. Here you see the 80 years of Alexei Abrikosov at his place. This is Professor Kadavaki, Professor Tachiki, me, Andreas Glatz, and Alexander Buzdin. Finally, it was official celebration of Abrikosov birthday symposium in Argonne. And this picture I did 2 years ago, being in Stanford University. I visited the cemetery where Alexei Abrikosov is buried. It is, we cannot explain this by any theory of probability, but his grave is located 200 meters from grave of his uncle, Dmitry Abrikosov, whom I told you was the envoy of Russian Empire in Japan. And after the Second World War, he immigrated to United States. He wrote his book and died in 1951 in Stanford, and their graves are close. So the the destinies, the incredible loops. I want to say that Alexei Alexeyevich Abrikosov will be remembered as a great scientist whose work influenced many fields of physics and paved the way to a new comprehension of superconductivity. He was a very bright man with a brilliant sense of humor, which helped him to overcome the difficult periods of life so full of events. Thank you for your patience.
Thank you very much, Andrei, for your very informative and very interesting presentation. And sorry for these annoying technical problems.
Does not matter.
Yeah, I'm sorry.
No, no.
And I want just to ask if somebody want to have some questions or maybe even some to tell something about this. But of course, we are very impressed for your talk from my side. I appreciate very much your time and your very informative talk. So,
thank you very much for this invitation and possibility to memorize my teacher.
Thank you. Anybody wants to add something, or maybe because we are somehow informal, maybe too informal, I'm sorry, but maybe some another opinion, or so, because our time is okay, so we still have some time, but
Arkady, maybe you will tell several words because you was a student of Moscow Institute Steel and Deloitte, and you listened to lectures of Abrikosov.
Yeah, indeed. I heard his lectures. I was listener. In fact, to fill the time, I already said something at the beginning. But of course, in my opinion, it was excellent teacher, excellent lecture, and it was. I was very lucky to be one of his students, and of course, this. So it affected my scientific life as well, because after that, so after graduating from the theoretical physics cathedra, I went to Chernogolovka to continue my job, and this is just my personal impression. So of course I'm very grateful to his teaching to me and so on. But of course, I think there are probably many other people who even working with Abrikosov or working in the same field. So I'm just asking if somebody else wants to add something. Nobody wants, so just I think we have to, yeah. There are some questions, please.
Alexander Shengelaya from Georgia. Hello.
Hello.
Hi,
Andrei. Thank you very much for this beautiful talk. It's really enjoyed very much, and it's very instructive and very interesting. I have a question. I heard that Landau for some time did not believe in vortices, and so he even forbid to publish. I don't know if it is true or if it is a legend.
Alexander, thank you very much for this question. Actually, it would be bad people could say that we organized with this, because I have doubts to speak about this, and then I decide someone will ask me. So
okay.
then I want to say that for Abrikosov, Georgia was very, for all of us, Georgia is a very special place. We so many memories about the Bakuriani Symposium, about Tbilisi. For me, this is Andrusha Pansulaya, who was my student, and a lot of friends. So, but now I will return to your question. Indeed, you're right. So the story of I told about the collaboration of Zavaritsky with Abrikosov. And those times, most prestigious publication in Soviet Union was considered in the Proceedings of Academy of Science, not in JEF. And when they found this discrepancy with the theory of Ginzburg-Landau, Abrikosov proposed to Zavaritsky to publish. He had some ideas, but he still did not construct the type 2 superconductivity theory. So he proposed to Zavaritsky, he told me this, to publish together. But it was the limitation of volume, 4 pages. So Zavaritsky, who was very precise, let's say, person, he thought, no, let's do the following. I will publish my 4 pages, and you will publish your 4 pages. And we will have 8 pages. And then they published these 2 papers. So in this moment, Zavaritsky lost the chance for Nobel Prize, I would say. Then Abrikosov started to study these experimental findings, and I don't know, it was 53 or 54, but not later, when he presented to at the seminar of Landau his paper, which we know by publication 1957. This is no Nobel work. Those times in Landau school was the Ordnung. You could not publish the article because you decided that you want to publish article. So actually it was necessary to have approval of the seminar IDEST of Landau. Landau did not believe on all this story, and he did not allow to publish his paper. Those times, Landau with Khalatnikov were working on the properties of rotating superfluid helium. And their idea was that some circular layers appears of normal and superfluid phase. So they just wanted to recycle intermediate state of Pyrrhus Landau on liquid helium. And this time in 1955, Feynman published his paper about the properties of rotating helium, and he introduced the notion of quantum vertex. So the momentum is quantized. Landau thought, oh, how we could not arrive to this idea. Feynman is great. This moment, Abrikosov approached him and told, no, Feynman is great for one vertex. Some time ago, I proposed you the lattice of vertex, and you told that this is shit. And Landau told, no, Feynman is great. Okay, you can publish. And so indeed, this Abrikosov's paper was published with considerable delay. This is what I know from Abrikosov.
Okay, so thank you very much. This was interesting for me.
Thank you again. And I would like to ask if there are so many more questions, or, and I think we have one more intervention. Is it right? So, yeah. So thank you again, Andrei, for your very interesting talk.
Ivan has a question, I think.
Yeah.
This is a question.
I thought that there will be one more lecture, but if we have empty slot, I could show some photos. Would you like me to show some photographs of Abrikosov?
Arkady, the question is for you. I will be very happy, Ivan.
Okay, whoever is chairing the session, yeah. Okay, let me try to see whether, can you see my screen?
Yes.
Yes.
Okay, so I was fortunate to be there in 2003 when Abrikosov received Nobel Prize. So I would like to show you some photos from that event. But the big picture is that, at least to my perception, he was a very modest person. Not as a physicist. As a physicist, he was actually pretty arrogant and harsh to almost everyone. But as a private person, he was, I think, very modest, and he shunned publicity. It was very different from Ginzburg or Phil Anderson or Bob Laughlin, people who like to be at the center of attention. He actually avoided that. But nevertheless, again, the rumor was that he was craving to get the Nobel Prize. He thought he deserved it. He was nominated like 20 times before he got it. And again, the rumor was that every year in October, he would be drunk for a day or two and then come back to work again. Eventually, it happened 2003. Here are the Nobel laureates in the Swedish Academy of Sciences. Ginsburg is here, Abrikosov standing there, and Leggett next to them. This is McKinnon for chemistry, and that's Goetze for literature. And the main event was, of course, the handing of the Nobel Prize plaque and then the medal by the king. And here are the laureates and members of the committee, members of the Swedish Academy of Science, and that's the royal family there. Here are the laureates, Abrikosov first, Ginsburg next, Leggett next to him. And here are three of them standing while the president of the Academy of Science is reading their citations. And here is Alexei Abrikosov getting the prize from the king. That's the royal family, king, queen, and that's Crown Princess Victoria, and that's his aunt, another princess. After that, there was a dinner, and Abrikosov got the first prize. Ginsburg, since he was like the senior by age, then he was considered the first, and because of next, and Leggett the third. So Ginsburg was sitting next to the queen. Nina Ginsburg was sitting next to the king, but Abrikosov was sitting next to this princess who was very pretty, and Abrikosov actually was not impervious to beauty. Here are two of them going to the dance ball. And that's Abrikosov and his wife after the party. That's the entourage. So here is Crabtree and Mike Norman. They were guests of Abrikosov. I was actually guest of Ginsburg, and that caused some friction, because at the first day of when they arrived to Stockholm, they were met at the airport by reporters, by news and TV, and they were asked a number of questions, and one female reporter from Russia actually asked her a provocative question. She said she would like Professor Abrikosov to explain why he left Russia, and Ginsburg to explain why he did not. And Vitaly Lazarevich was always very fast and also pretty, knew to be pretty harsh. So he said, well, I am not the one who needs to do any explaining. And that hit home. So Alexei was offended. And till the end of it was whole week of this celebration, till the end, he actually never stopped to talk to Ginsburg, and he actually boycotted all the subsequent press conferences. So he didn't come to the press conference with the three physics laureates. They were supposed to be talking all three. Ginsburg showed, and so did Leggett, but Abrikosov just didn't show. And that put me in some kind of unpleasant situation, because I was friends with both of them. And since I was a guest of Ginsburg, then I went to all the formal events with Ginsburg. But then in our free time, I was hanging a lot with Alexei, and we talked physics a lot, both with Alexei Abrikosov and with Ginsburg. And our talks were actually looked like quarrels, someone from outside, like we were quarreling all the time. And that's because I was challenging their theories. They both have theories of ITC, and both of these theories were wrong. And I was proving that to them at every point in every occasion. Of course, I knew better than to fight on the theoretical grounds, but what I would do is I would trip them with experimental facts that actually contradicted their theory. And they were always interested to hear that, both of them equally. They sought my company and asked my opinion, or rather information that I could give them, because I was at that time pretty much following everything that was done in high TCR experiment. And more than that, I could tell them which experiments to trust and which not to trust. There are many, many experiments that are wrong. And I could tell them which are wrong and why they are wrong, and which to take seriously. So anyway, that was it. So you see how is he dressed, and that's how he was dressed most of the time. That's some old sweater that he was wearing. I think I saw him in that like 10 years before, and that he was wearing there. And I was standing next to him, in black jacket and tie and gray beard and glasses. So reporters, when I was talking to him, they were also taking photos of me and not of him. They thought that I looked more like a Nobel Prize laureate, like aloof, and he looked more like someone from the maintenance. So he was very, 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 very modest person, very honest physicist, and it is sorely missed. Thank you. That's all what I want to show. Oh, there is one more thing. There is one thing on which Gorkov and Abrikosov, Abrikosov and Ginzburg agreed during that conference, not to one another, but when I talked to each of them separately, and that was the role of Gorkov and his place. Lev Gorkov was actually very embittered by the fact that he was omitted, and after this he was not only angry at Ginzburg, for example, but with anyone else associated with Ginzburg, including myself. But I think it was very unjust. He somehow thought, or someone told him, that they opposed his nomination, but that was not true. Both of them told me, and I think these are people, neither of them would lie, that they thought that he deserved it equally. They thought that it was a GLAG theory, Ginzburg, Landau, Abrikosov, Gorkov theory, with Landau dead. So it should have been Ginzburg, Abrikosov, and Gorkov, both of them. And whoever opposed Ginzburg's nomination, that was neither Abrikosov nor Gorkov.
Okay, thank you very much for your interesting intervention and the interesting information. And thank you again. Just I want to ask if anybody wants to add something or share any new information. And I think this is time to close this session, because we are already on time. And to thank all the people who wanted to share impressions and for very interesting and informative information. Thank you again, and sorry for some technical problems again. Thank you. And in this session is closed, and thank you all attendees to attend this session.